So all these, so I keep saying that basically we're going to use the term tree here, and I've been saying like stacks, data structures, people, computer sciences, we really named that correctly. Queues, we named that correctly. Trees, we named that correctly, but we kind of are terrible at drawing. I guess we just don't go outside enough because all of our trees will be drawn upside down with the root at the top. So just keep that in mind. It's more of a family tree kind of thing going on there. So a tree is a collection of elements or nodes, and every node is linked with its successors, plural. Okay, so this is a basic tree over here with 4 nodes in it. Okay, this node at the top, we call it the root of the tree, right? Because it is the most important guy, he's at the top. Now, right, like I said, our trees in data structure, we're gonna have the node at the top be called the root, as you'd expect roots to be at the bottom in the ground, but this is more of like, the way we display these are more like family trees with the older and, thing at the top, and there's less things at the top, and just if you get further and further down a family tree, you get more and more children, right? So we're going to use both basically the gardening terminology but we're going to display it like a family tree. So the node at the top of the tree is called the root, and it has these successors, and it's linked to its successors with links we call branches. So, like you can have a branch of a family tree. Now, don't get too hung up on this particular terminology. If you call this a link, this line a link, or if you call it a branch, everybody's going to know what you talk about by the context. It's perfectly fine to call it either of those. Your successors, right, if we look at this from a family tree terminology, then the successors of a node are called its children. Since this is a binary tree, we refer to them as their left child and the right child. So dog's left child is cat, dog's right child is wolf. That's your successor. So rather than having a next, you have your left child and you have your right child. Your predecessor, meanwhile, is called your parent, right? So we kind of established a parent-child relationship, right? Cat's parent is dog. One of dog's children is cat. So everybody has exactly one parent, except for the root node. He doesn't have a parent. Okay. And so we will just simply leverage this as well as we can. So if you have the same parent, you are sibling nodes, right? So cat and wolf are sibling because they have the same parent, which is dog. Canine's parent is cat. Cat's parent is dog. Can you guess what we call the relationship between canine and dog? If you guess grandparent, that's not the term we use, but guess what? Everybody will understand exactly what you're talking about. It's perfectly fine. I've never seen it put down anywhere formally, but I've seen it described everywhere in algorithms that this guy, canine, that canine's parent's parent is his grandparent, right? So the generalized term we use is dog is canine's ancestor and canine is dog's descendant. Okay? So if you're at the bottom of the tree, you have no children, you call the leaf node. So canine is a leaf node, wolf is a leaf node. They're also called external nodes, but I'm going to just call them leaves or leaves, right? And if you're not a leaf node, you're a non-leaf, or you are a internal node. So this is just simply repeating what I said, but it should have gone earlier because slides are like that. The generalization of a parent-child relationship is the ancestor-descendant relationship. Dog is the parent of cat. Cat is the parent of canine. Canine is the descendant of cat. Dog is the ancestor of canine. So now what makes it recursive is that we look at this as your left child and your right child. They are each the root of their own subtree, right? So a subtree is a tree whose root is the child of that node, right? So this is its own subtree, and I'm going to draw one on the board. I'm going to have a second one up on the board in just a bit. And wolf is a subtree, is the right subtree. So, and the important thing over here is that the subtree is a tree, is that these subtrees can be any size, right? Canine and wolf are their own subtrees, right? Cat and canine are a subtree together. But dog, cat, and canine aren't a subtree, right? It would be all 4 of these guys would be a subtree together. So cat and canine is a subtree, wolf is a subtree by itself, right? Because it starts at my left child and it starts at my right child. My left child has his own tree, my right child has his own tree. Make sense there, hopefully? Okay, and then we also have this final terminology. Level is the distance from the root, right? So dog is at level 1, cat is at level 2, canine is level 3. Pretty easy to figure out there, right? You can define that recursively, saying that basically it's your distance from the root plus 1. So it's if the root of the tree, my level is 1. Otherwise, my level is 1 plus my parents' level. And the height is basically the longest path from a root to a node. So the height is 3 because, right, 1, 2, 3, the maximum level. All right. So I'm going to go ahead and do a second video just simply to go over these topics. Okay? One more time.